Welcome, dear students, to your number pattern series, and this is your lesson 3. We are still going to do our quadratic sequences in this lesson, but we are going to mainly focus on finding the unknown that will be in the quadratic number pattern. So we are going to try and make this lesson short and sweet, but before we get to the end of it, we have to learn the skill that I want us to get. So let's go to the first example over here. So we were given the quadratic number pattern, which is 1, it's 7, there is x, and there is also 31. So we were told it is a quadratic number pattern. So what we know for a quadratic number pattern is that the second difference is constant. We have to keep that in mind. That is what we are really going to use in this lesson. So let's go ahead and get to that second difference, which is supposed to be constant. So 7 minus 1 will still give us 6. And then here when we subtract this one, it will be x minus 7. Unfortunately, we have to write it like that, and then this one will be 31 minus x. So the first differences are usually not a problem to write, but the second ones you may want to be careful. In actual fact, I am asking you to say x minus 7 minus 6. So can you see how that is going to be x minus 13? You have to see it either exactly here or by doing it on the side. Well, let me show you. If you want to do it here, all you have to say is, you take this negative x here, you say negative x minus this x over here. So you say negative x minus this one. So that will be negative 2x. And then you say 31 minus 7. You are noticing that it will be positive 38. But if you are not able to do that one by just looking at it like that, you are free to do it on the side. Like, for example, doing it here, it's not a problem as long as you're getting things right. So, look, I am doing it separately. So you'll be able to say 31 minus x, and then that one will be negative x, and then you see plus 7. So that's how you will know 31 plus 7 will be 38 minus 2x. So minus 2x plus 38 and 38 minus 2x are one like the same thing. So here is the thing. After we get to our second differences, which are these ones, remember those are the ones that we use. Those are the ones that are constant. So we use the fact that they should be constant to get to our unknown. So if this was a 2, this should also be a 2 from what we learned. So therefore, we are going to just write an equation equating the 2. So therefore, I can write, since the second difference is constant, it means x minus 13 should be equal to negative 2x plus 38. That's all you do, and everything else will fall right into place. I'm taking x to the left-hand side, and 38 plus 13 should be a lovely value. Let's get, it should be 51 over there, right? So let's get our x value. So 51 divided by 3, luckily that's a simple one. So we got our unknown that was in the equation, and we got it to be equal to 17 by using the fact that we know that the second difference is constant. So that is all there is to it. Now, after you get your 17 as your unknown variable, which was x here, now you may be asked to find the general term. I hope you have not forgotten how to do that. So let's write those terms again. In place of x, let's put the 17 and put the 31 here. So if you want to find the nth term, you have to get to your differences, even to your second differences. So let's write that down quickly. It should be easy to notice what we are doing here. So when we subtract these two, we should get, this one would be a 6, and here we seem to have 10, and here 14, definitely 14. All right, so now when we get that one, now we can go and get the second differences and see, since this is a quadratic, it should be constant over here. So I'm seeing there is a 4 here. 14 minus 10 will still be 4. Since what we want is the general term, remember you say 2a is equal to the second difference. It's just these three that you use, these ones. And then your 3a plus b is going to be equal to 6. And then your a plus b plus c, that one is equal to 1. So keep that in mind. That is what we said we must use all the time when we want to solve this one. So dividing both sides by 2, you should get a of 2. And then when you get a of 2, you come and substitute it here. So you can get b. Our b value is going to be 6 minus 6. We don't struggle with such things. So we have 2 here, we have 0, and we want to find c. Let's see if we can get it. What is 1 minus 2? That's definitely equal to -1. So from what we know, our general term for quadratic number patterns should look like this, right? And therefore our Tn in this situation is going to be 2n squared plus 0n minus 1. So this right here will be the general term in this particular question. All right, so let's go ahead and calculate another unknown, and let's see if you will be able to get the point. Well, in this one, I just thought let me give you the one that has 2 unknowns and see if you will be able to handle it. So as you are noticing, you may have to exert yourself a bit more than if you only had 1 unknown. So let's go ahead and solve this one. Okay. So, oh, there is something else you were told here. You were actually told the second difference. Even if you were not told the second difference, right, you should be able to solve stuff like this. But let's do it since the second difference is given. I'll show you what you were going to do if the second difference was not given to you. So let's first of all do it with the second difference of 2. So let's get the first differences. We know we have to say x minus 4 here, and then 8 minus x, and then y minus 8, and then you seem to have 20 minus y. If you're not careful when you start subtracting these ones that are here, you may make a few mistakes, and that will not be very lovely. So that is why you may want to do it separately and see what's what. So let's go ahead and do it the way I asked you. So if you say this minus x, you have to change the sign of the things on the left-hand side. So you get your negative 2x. Then you say 8 minus 4. So it will be 8 plus 4. That will be positive 12. If you are not grasping what I mean, I said you can go on the side and say 8 minus x, and then you say minus x minus 4 like this. And then this is how you will notice that things will still, you will still get things, the same things as we have here. So as you can see, negative x and negative x will give you negative 2x here, and 8 plus 4 will give you the 12 that we're talking about. All right, so let's go and see if you got what I said. In fact, why don't we just do it on the side, all of them, so we won't have to do it 2 times. Everyone will be able to get it when I say y minus 8 minus 8 minus x. So let's simplify this. So you can see when I try to simplify it, this is all that happens. Then this becomes a plus. It does look like I'll have y minus 16 plus x. So forgive me, I would like to write it as x plus y minus 16. It's the same thing. Well, the last one, it's like we will be saying 20 minus y minus y minus 8. Okay, I'm doing it as if we didn't know that the common difference or the second difference was 2. So let's simplify it. Now this is 20 minus y, and it will be plus 8. So as you are noticing, when I simplify this, notice it will be 28 minus 2y. So we can just write here 28 minus 2y. Okay? So we got to our second difference. That's the important part. If you get to your second difference, you are correct, because that's the one you need. That's the one that's constant right there. So keeping in mind that the second difference is constant, let us equate these ones. The only problem, or the only good thing about this question, is that you were told that the constant difference is 2. So if you want to calculate x, I can go in. It means there is a 2 here everywhere. So what I mean is the minus 2x plus 12 can easily be equated to 2, and then you get your x. So from what we are gathering here, this will be negative 10, and that will leave our x as positive 5, isn't it? So you can calculate your x value like that. I'm using the fact that we were told the second difference. And then, well, since this part as well will be equal to 2, I can go ahead and say 28 minus 2y should be equal to 2. Meaning I can leave 2y this side and say 2 minus 28, I should get negative 26. So when I divide both sides by 2, I should be able to get y value of 13. So you see, I calculated it using the fact that the answer, or the second difference, was given to be equal to 2. But it's not all the time, you see, that you are given the second difference. So let's just say it was not given. If you were not given that the second difference is 2, what were you going to do? Well, let me show you that you were going to still be able to do that. I may have to put some things back. I have to do it in my head again, quickly. I think I have minus 2y there, and it should be 28. Okay, good. So that's what we have for that one. It's x plus y minus 16 over here. Okay. Well, what if you didn't know? In fact, let me just remove this whole thing, since you already have it as your solution. You will, if you didn't know that the second difference was 2, you were going to equate these second differences if that part was not given. So how are you going to solve it? You're going to do it this way. For example, you could say minus 2x plus 12 is equal to x plus y minus 16. And then you simplify this until it looks like an equation you can handle. So I am going to leave y alone this side and see what happens on the other side. Notice I'll get negative 3x when I take x to the other side, and 12 plus 16 will not give us problems. Let's have it as positive 28. I'm going to call this one my equation number 1. You see, I equated that one and that one. So to get the second equation, because I want to solve for x and y, I may equate this one here and that one. You can equate whichever two differences that you've got, as long as you are equating them. So I'm going to say, well, now x plus y minus 16 is equal to 28 minus, that has got to be 2y, minus 2y. Okay, I tend to then, okay, like that. So once that one is solved like that, you can now simplify this until it looks the way you like. So let's go ahead and make it look exactly the way we like. So we already have our equation 1, so we can now just put perhaps 3y this side to the left-hand side. Notice we'll have 3y, y plus 2y. After that, you're going to have to take x to the other side. It's actually already here. And then you take 28 to the other side, or rather 16 to the other side, and make it 44. So at this point, you can call that one your equation number 2. So after you get your 2 equations, now you can solve them simultaneously. Most of you do not struggle solving equations simultaneously. You equated any 2 of your second differences and you got your 2 equations, this one and that one. So I'm going to say in place of y, wherever I see y like there, I'm going to substitute the equation 1. So in other words, I'm going to substitute equation 1 right into equation 2. So what I'm saying is you say 3 and then you put minus 3x, notice minus 3x plus 28, like that. And then you're going to equate it to, remember we are here, we are copying this equation. So I just finished saying 3y now. So I have to say plus x is equal to 44. So from here, we should be able to get to where we want. So this will be negative 9x here, and then 3 by 28. Okay, that should be 84, right? So let's put that one as positive 84, and then let's put plus x is equal to 44. So I am going to say minus 9x plus x. You are noticing how that will be negative 8x, like this. And then 44 minus 84. So we are going to have negative 40 here. I think everyone can see how we will still get x of 5 if there was little or less information given. So once you get your x is equal to 5, you can substitute it into any of the 2 equations that we have. In actual fact, substitute it in equation 1. That will help me a lot. So y will be negative 3 by 5, and then you say plus 28. As you can see, your y value will still be 13, like we got it the first time. So perfect. I hope you're getting the whole point of doing it this way. So let's see now if you will be able to carry on and answer a question such as B. Well, now that we got our x and y, it's time that we write the terms down so we can get which term is equal to 1 to 5. Let's go for it. So you have to remember the terms. So it's 4x and 8. Okay, so 4x is 5 and then 8. Then what comes next? We have, we have y and then 20. So our y value is 13, and then we should have 20. We would like to figure out which term is equal to 1 to 5. They gave us a term, they gave us Tn. So we may want to find the general term first, and then substitute 1 to 5 in it, and then from there we will be able to do this. I'm not going to waste your time since you already know how to do this. Let's get our differences. Here it's 1, there is 3, and here it looks like it's 5, and here it's 7. Well, perfect. Our second differences are constant, people. So since our second differences are constant, we know exactly how to get the general term. You use these 3 like I have indicated. So 2a is equal to that, and then 3a plus b is going to be equal to 1, and then a plus b plus c is going to be equal to 4, like that. So let's get to everything that we need or that we've got here. Our a value is 1. Very simple to see. And then now if you substitute 1 here, you will be able to get b in no time at all. 1 minus 3, that will be negative 2. So far we have our a and b. Let's get our c. We are going to substitute 1 there and substitute minus 2 in place of b. So let's see what the c value will become. So 4, you see 1 plus minus 2 will be minus 1. So 4 plus 1, I think our c value should now be equal to 5. So getting the general term here is not going to be difficult. Your a is 1, so it's 1n squared plus bn squared, which will be minus 2n plus 5, like that. That would be our general term. But, well, we were not asked for the general term. We were asked where 125 is. So you have to come to Tn and substitute 125 there and solve the equation. That is all you do with that. So let's go ahead and do the sum. It's not an issue solving a sum like this. So 5 minus 125 should still be 120 over there. So make it a point that you have it. Well, if you remember the equation that I want you to use when there are big numbers like this, well, you can find two factors. It's possible, but it's better if you go through this formula. There is no need, you remember the quadratic formula, right? O over 2a. So what I am saying is, to get your n, you can as well substitute and say minus 2. That's our b. Plus or minus square root of b squared, which is minus 2 squared, minus 4ac. Our c is negative 120, like this. So it's all over 2a, which is 1 in this situation. So it's a calculator's job, really, or you can do your factorization if you would like to. So at this point, I am getting the n value of 12, and on the other value, I am getting negative 10. I like the fact that it's not a natural number, this one, so that will not be the solution we want. So it is actually T12, which is equal to 125. So very simple to see, really. Well, I have calculated quite a number of unknowns, so it's your turn now to have a practice question, calculate that unknown for me, and solve these terms that are here. I hope you'll be able to do that. Well, if you did it, well done for your hard work. So let's go ahead and do it together now. So the terms that were given to us is negative 4, and then we have x, and then we have negative 28, and we have negative 46. So what we want to do is to calculate an unknown. And I say to you, if you want to calculate an unknown, get to your second difference if we are dealing with quadratic number patterns. X minus 4 will be x plus 4. And then here it will be negative 28 minus x. Are you noticing? And then here we need an actual value, you see. So here, negative 46 minus 28. So we'll get negative 18. You can use your calculator here. Well, let's get this difference. By the way, this is the part where I said feel free to do it on the side if you cannot do it all in your head. And then you have x plus 4 like that. You can first of all simplify it on your own like this, and then you can then write the solution when you are very sure. You can see that this is going to be negative 2x, and those two will give us negative 32, isn't it? So you become more confident about writing the solution here as negative 2x and minus 32 when you subtract those two, okay? Like I said, you can see it easily. If you see it easily, it's fine with me. If you don't think you are seeing what I'm asking you to, then make sure you do it the way I'm asking you. So if I do it the faster way, I'll say 0 minus x, that will be positive x, and then minus 18 plus 28, I'll get 10. So for those ones that did it the other way around, they did it this way. Minus 28 here, minus x. As you can see, this will be negative 18 plus 28, and then plus x, which will give you x plus 10 as we have already indicated. So you can do it on the side like this. Nobody will judge. All right, good. So now that you got to the second difference, that's the one that is constant in a quadratic number pattern. So since the second difference is constant, you are allowed, you are free to equate this one to that one because it's the same. They should be equal. So I'm going to take 3x to this side. If I take 2x to the other side, it would be positive 2x. If it was negative 2x. And then negative 32 minus 10, that should be negative 42 now. So dividing all of that by 3, that should give us negative 1 there and 4. So that's negative 14. So that's our x value. That's the unknown. I hope you got that x value easily. Well, from there on, you were also then asked to determine the general term. So it's a matter of you going to substitute x there. So let me write that again. Negative 4, and your x was negative 14. This was the term you needed. Everything else, you had it. Look at the top there as we are copying this equation again. Well, at this point, since it's the general term we are interested in, let's just quickly get the differences and get it right. Well, this one is negative 10 for those ones that are doing it right. And then minus 28 plus 14 is minus 14. So it will be negative 14 here. Negative 46 minus 28, that will be negative 18. So when you get your differences, make it a point that you're doing it accurately. I'm getting negative 4 here. And negative 18 minus 14 is also negative 4. Interesting. So the moment that one is constant, you go ahead and equate it to 2a. Our 3 things that we use, I hope you have not forgotten those ones. And then the other equation is 3a plus b. You equate it to negative 10. And then a plus b plus c is equal to your first term, which is negative 4. So make it a point that that one is done properly. Okay, so that is negative 2, isn't it? Our a value here. Let's just write a properly. Okay, something of that sort. That's our a, which is negative 2. So if I come and substitute negative 2 here in place of a, I should be able to get my b value in no time at all. So it's b negative 10 plus 6. Okay, that's how we are getting b here. And you are noticing that that would be negative 4. Well, after we have those two, now I'm substituting them here. Negative 2 in place of a, negative 4 in place of b, and now let's see what c can do to us. The c value is now going to be, this will be negative 6 yet, the two of them, isn't it? Negative 6. So when I take it to the other side, it will be positive 6. So negative 4, this negative 4 here, then you have to say negative 4 plus 6. Yes, negative 4 plus 6 should give us a c value of 2. Okay, good. Right, now at this point, I would like to think that everyone is aware that all quadratic number patterns have that general term, and it's only the values of a, b, and c that differ. So here our a is negative 2, our b is negative 4, and our c is positive 2. So that, people, is the nth term. You were asked to find the nth term of the sequence, and here you have the nth term. It's normally 4 marks that you get for doing absolutely nothing. Okay, good. So here is what we have. I would like to just give you one more skill since we have a bit of time. I would like to show you that they may give you some patterns, okay? Some drawing that you have to figure out what type of a pattern you've got, and then after that you may be asked a few more questions. So let's have just one like that before, 1 or 2, and then we should end this lesson. Right, so we'll be extracting information from the pictures that are given to you. So for example, here I'm going to challenge you to count the number of dots that you are seeing on the board. So I hope on figure 1 you are seeing that there is only one. These are beads actually. Let's just call them beads, the red dots. And then on figure 2 you can count them. They are actually 5. You see, I still have that one correct over here. And then figure 3, let's give you some time to add. I have already added mine, so it's already here. It's 12. Maybe the annoying one will be figure 4. So I will really give you a minute, not a full minute. Add them. Well, if you did it right and you did not make mistakes, you should get 22 over there. That's the correct number of beads, the red dots that are there. Well, the drag is if you have to keep counting. If I were to draw figure 5 and figure 6 and figure 10, you were going to start wondering, how am I supposed to add these beads without making mistakes? And that is where our number patterns come into play. They check if there is any pattern in the numbers you're getting, and then from there on, you can decide even big numbers, or even, let's say, how many of these beads will be there in the 10th bead, in the 10th shape, or something like that. So at this point, I'm noticing there is a pattern, but for you to also understand what type of a pattern we have, I'm going to have to just show you the first differences. Do you see there is a 4 here, and a 7 here, and a 10 over there? And if I do this, notice there is a 3 and a 3. The moment you see that the second difference is constant, it tells you that you are dealing with a quadratic number pattern. So since it's a quadratic number pattern, this you were asked to give the number that will be in figure 5. From what I said, that would be like being asked for the next term. From what I said, you just add these ones. So if you add them properly, you should get to your 35. Right there. So you would have done a big job of adding beads by just doing a bit of math. Well, getting figure n, it means you're being asked for the nth term. What is the formula we can use to calculate the number of beads? We have already done a lot of these, so I'm just going to do it without really explaining what I'm doing. I think you understand this very well. So this is what you do. You equate it again to 4, right? And then your a plus b plus c, you equate it to the first term, which is 1. So we already have a few things here. We already have a, so I'm going to get b now. Let's see. So 4 minus 9 over 2, that's actually negative a half. So that's your b value. And then here, if I put 3 over 2 here and minus a half, and then I have c here, and then I have 1. Oh, 3 over 2 minus a half will give us 1. So 1 minus 1 will be 0. So we don't have c this time around. So in our normal formula, which should look something of this sort, an squared plus bn plus c, the c value is 0. So our general term will now just be 3 over 2n squared minus half n plus 0. So this will be the nth term that you are going to put at that box up there. So please, people, you can be given a pattern or something to think about for you to identify what row is going on, what pattern is going on, and you should be able to do that with no difficulty at all. Well, just to tease your brain a bit, I thought let me give you this one as well. Look at this one. If you have enough time to read this, you have a plant which is growing as a single shoot at first, and then each one is splitting into 2, as you are noticing. 2 new shoots branch off from the first one, and at the end of the month, a flower blooms at the tip of each new shoot, and this growth pattern continues as you are seeing here. Well, this one, I'll let you think about it on your own and figure out how many shoots will be there on a 5-month-old plant. So think about it. It's quite interesting to actually figure out what's happening there. Well, I think here it's not, remember, these things are not always It's not like they should always be perhaps linear or quadratic or something. Look at the flowers. The flowers are going like this. If you have one, the next month it seems like you have double, which is double the first one, and then here it doubles and then it becomes 4. So you can tell that the next one is going to be 8, and even the next one is going to be 16. You can easily tell. So here, that is a month old, that's a month old, that's 2 months, and that's 3 months, that's 4 months, and that's 5 months. So if you would like to see how this plant is growing, please, you may read the statement all the way up there. Well, these are the flowers, right? What about the shoots? Let's see if we can see a pattern. Well, the shoot, we are talking about this thing here, okay? So that's 1, and then here it's 1, and then there is these 2, which is of course 3, and then if you count those ones, it's 7. This one is a bit difficult to see exactly what's going on here. So if you would like to know how many shoots will be there in a 5-month-old plant, I hope you notice the trend here. It's actually just us adding these 2, isn't it, to get this one. And then if you add these 2, you get this one. So to get the one for here, you have to add 8 and 7. You should get 15. And to get the one for the 15th month, you have to add 16 and 15. And you should be able to get 31. Otherwise, you have to continue drawing like that. So it's not exactly a particular number pattern that you can see or that you can easily pick up, but at times you're just required to think. And thinking is something that we all like to do, isn't it? So I hope you enjoyed this lesson. Thank you very much for watching this video. I will see you next time.